Dear students, welcome to our lecture series on fuzzy logic engineering. In previous lecture, we have discussed about two methods of fuzzification. One is intuition and another is inference. And in today's lecture, we are going to discuss a new method of fuzzification that is based on neural networks. So let us see. So this is the generation of membership functions using neural network. So when we use neural network, then input data is divided into two parts. One is training data set, and other is checking data set. Training data set as well checking data set. This training data set is used to train the neural network. So the data points are divided into different classes. Like suppose this is the representation of training data sets. In the two dimension we can represent the training data set, and this training data set is divided into, let's suppose, three regions: R1, R2 and R3. Like this R1, this is R2 and this is R3. So we can write like R1, R2 and R3 into three different regions. This data is divided. Then we created a neural network here which is having three layers. This is a general structure of neural network, in which this is input layer, then this is called hidden layer, and this is called output layer. So these are connected. These are different neurons in the network. Then like every neuron is connected to other one, and we are getting output here, and output is three regions. We can denote this one like this. This is a shaded kind of part is there. So we can say that this is R1, this is R2 and this is R3. Here X1 and X2. Now what we will do, we will take the training data set one by one. Suppose this is X1 and this is X2, and let's suppose this is first data, then second data, and so on. Suppose first data is 0.7, second data is 0.8. So we represent this box by this neural network X1 and X2. This is our neural network, and it is giving you three outputs: R1, R2 and R3. And these three outputs are represented like this one. This is R1, R2 and R3. So this is for first data. Now suppose first data is 0.7 and 0.8. Now here we will represent all these data. So 0.7 and 0.8, it will be around here. 0.7 and 0.8, it will be around here in the region R3. So when it is here in R3, so we will mark for the data point first R1 membership 0, R2 membership again 0 and R3 it is 1. Then we can take second data like 0.8 and 0.2. So 0.8 here on the x-axis, 0.8 and 0.2, it will be around here. Then since it is belonging to region R2, so for the second data we can write membership value in region R1 is 0. It is belonging to region R2, that's why it is 1 here and 0 here. In this way we can mark all the training data set and corresponding values into the different membership R1, R2 and R3. So basically this is mapping the coordinate location. These are the coordinate locations we can write here. This is neural network is coordinate locations are mapped into membership values. So when we represent all the data to the neural network, then our training part is completed. Training completed, and when training is completed, then our neural network is ready to give the output. So we can do the next part is the checking. So whenever we represent some checking data set, so suppose a single data point we give to the network. Suppose x1 is having value of 0.5 and 0.5. This is single data point. This is given to this network. Here inputs are x1 and x2 and we are getting outputs R1, R2 and R3 membership values in the 3 regions. Then we will get the output in terms of the membership value into 3 regions. So we can get the membership value R1, R2 and R3. So when 0.5 and 0.5, here we can see it is 0.5 and 0.5 somewhere here it is. So we can here see that it will have a very less value, less belongingness to R1 as well as in R3, whereas it is having highest belongingness to R2. So somewhere we can get like R1 is 0.1, R2 is 0.8 and R3 is 0.1. So in this way this neural network can be used for the fuzzification, and we can represent the membership values here also, like for this data point R1, R2 and R3. So R1 0.1 here, R2 suppose it is 0.8 and R3 again 0.1. So in this way, and this is for data point x1, x2 equals to 0.5 and 0.5. So in this way we can generate the membership function using neural networks. So this was all about the new method of fuzzification that is based on the neural network. So if you have any query regarding this method, you can put your queries on my mail ID that is given in the description box.